Okay, so let us start today's session with some problems. Okay, to know the approach of solving questions. It is not sufficient to just know the theory. Particularly, the ray optics chapter involves a lot of concept and its application. We'll start with basic questions. Okay, so let us start with this question. A man of height 1.8 meters is standing in front of a wall. The sun is exactly behind him. Okay, sun is exactly behind him. His shadow has a length of 1.5 meter on the ground and 0.75 meter on the wall. Find the length of his shadow on the ground if the wall is removed. Okay, let us try to understand the question. What it is. So the sun is exactly behind him. What does that mean? Let us try to draw. So suppose that there is a person. Let us represent person by just a line, a straight line. Okay, so this is the straight line AB. This AB represent a man, and I will draw the horizontal line. So this is ground, and there is a wall also. Wall also I need to draw. Okay, ground 0.75 meter. The sun is exactly behind him. Okay, his height is given as 1.8 meters. 1.8 meter, and sun is exactly behind him means what? What does that mean? So do I take sun behind him means exactly behind where? That is what we need to understand. A man of height 1.8 meters standing in front of a wall. So there is a wall. Wall also will have some length. How much length we don't know, but you can take a big wall. Big size wall you can take. Okay, right. The sun is exactly behind him. His shadow has a length of 1.5 meter. His shadow is coming small. Okay, I think if you look at his shadow, it is showing that its shadow is 1.5 meter. Okay, on the ground it is 1.5 meter and 0.75 meter on the wall. So on the wall it is looking still smaller. Okay, let us say like this. This is his shadow forming here. Okay, this is 0.75 meter. His shadow is forming like this on the wall. What about on the ground? On the ground it is 1.5 meters. So on the ground it may be like this way, 1.5 meters. Okay, so these are the shadows. Find the length of the shadow on the ground if the wall is removed. How to attempt this question? What is your idea? All of you can think about it. Try this question. The sun is exactly behind him means that also is a confusing word. Where the sun can we take, right? And if the wall is removed, also they have not given the distance between the man and the wall. That is also not given. A man of height this is standing in front of the wall. The sun is exactly behind. Should we consider sun exactly behind means can we consider sun like this? Here, sun. Ah, what is longitudinal magnification? No, lateral longitudinal means there is a principal axis. Where is the principal axis? That also you need to tell. Where is the principal axis? And then we can go. Try this. All of you try this. Do some calculations. Then we'll discuss. Okay. All of you try this. And the diagram which I have made, is it correct 100% or not? That also you need to see. You also try to make your own diagram. All of you try this. Anyone have any idea how to do this? Sun is exactly behind him means what? The source of light is exactly sometimes things are not clear, we have to interpret it properly from the question. So man of height, this height of the man is clear, right? He's standing in front of wall. Okay, he's standing in front of wall. Sun is exactly behind him. Sun is here. Okay. His shadow has a length of 1.5 meter on the ground. Ground's length is 1.5 meter. Okay. And has a length of on the ground and 0.75 on the wall. Find the length of his shadow on the ground if the wall is doing. So behind means what? I think this word behind is a confusing because sun is not a small object which can be behind. So might be we can consider that this way that side sun is there and light will be coming from sun like this way. I think we can consider like this, isn't it? So light is coming from sun might be like this, isn't it? Might be like this. So if you consider like this, so what can we do? And it's about the formation of shadow. So light has to hit here. From here, can we consider it like this, that these rays which are coming here, this forming, let us try to connect this. So if I connect it light from here like this, that means this point 8 shadow means it is not like reflection. Shadow means when light is coming like this way, light cannot pass through this. So that's why, because light cannot pass through this way, here dark things comes, dark things, right? So hmm, this is shadow on ground, that is shadow on wall. That's what they have given. They have not given uh, much information about it. They have not also given that wall and ground means how much distance from wall it is. Man is standing how much distance, that they have not given. Okay. Only thing that we can assume that this parallel rays are coming from sun, that is what we can think about it. And this is like one of the parallel rays. So from here to here it is coming like this way. That's what we can think about it. So if we think like this way, this way we can try to explain this something we can. Should we consider reflection from the ground? That is also one thing we need to note. Should we consider reflection from the ground? And note that on the wall it is very small size. Right? This wall its size is small. I think on the ground directly we can assume that it is coming and it is hitting like this. What do you think? Rays we need to take parallel only. These are sun rays. Sun rays we have to take parallel because sun is at very far away, infinite distance. So you can assume that sun rays are parallel. I think that is the key idea. You have to assume sun rays as parallel and start doing something from that. Correct? What do you think? I think if you see, if you think it like this, from this way, I think this diagram is correct. But how to draw that diagram? How to draw that diagram? That is not becoming very clear, right? On the ground and on this wall, this ground we can see if it is coming at an angle of horizontal theta, this angle we can calculate definitely because sun ray will be coming like this way, right? This is how sun rays are coming. So we will be able to find out at what angle this is happening. But I think this 0.75, this is not going to give clear idea because if you see here it is hitting, till here it is coming. But now wall is wall exactly 1.5 meter? Because if you consider here wall, it is not going to make image on the wall. Are you able to see that? See, I think this is where we have to apply logic. Question things have not given clear, we have to apply logic. So if the rays are coming like this, like this rays will come definitely, these rays will not be able to go that side, these rays will not be able to go there. So that means this image which we are forming, this image, not image, sorry, this is like a dark shadow. So this is okay, but then wall is away now, there is no wall here. So wall shadow will not form. That means wall has to be little bit closer. How much closer it is? Suppose if you keep wall closer by 1 point lesser than 1.5, then this shadow will reduce. I think we need to shift the wall here itself at this place, and then we need to change this direction also. Okay, so let us do like this way. We little bit let us alter this diagram. Okay, I am just getting the idea. Based on that, we will redraw this diagram because things are not clear. We have to understand it ourselves. Nobody can help. We have to think ourselves. We have to become independent. Okay, so if I consider that there is a wall here, this wall is 1.5 meter. If this wall is beyond 1.5 meter, then shadow cannot form on the wall, right? It is not possible. So what we do is, let us keep it here and it is coming at some angle. So this already we decided that this is the shadow on the ground, and then we have to keep some shadow on that. That also is smaller than this. Okay. So shall we keep rays like this way at like this way? Might be rays you consider like this way. Okay. If you consider like this way, then if you look at this images, means shadow on the wall, so up to this much on the wall it will come here. Up to this much it can come. So on the wall, if I look at the shadow, I can say this is possibilities. Yes, this much will be possibility on the wall, and on the ground This much we have to consider on the ground. I think this direction you have to draw properly. This direction we need to draw properly. Suppose if you remove the wall, maybe some length can also come here, because see, if you remove this wall, then some length, extra length will come here, correct? On the ground it will increase, right or no? Yes, are you understanding this? Yeah, that is what I'm thinking, that's what it is. If the wall is not there, length of shadow will be more. Because of the wall, some shadow is coming on the wall, which will come on ground, that is coming on the wall, right? That is what it is. I think this is the correct idea we should think about it. Okay, now I think we need to do calculation here. How to do calculation? So, okay, this distance is given as, this length is given 1.8. This is 1.8, and this length is 0.75, and this is 1.5. You mark it, So you mark it. This point is like A and this point is B. Here this A will come here. Okay, this A means it's shadow, not that reflection it is the shadow of that. Okay, so this A and B. No, see, it's not that shadow length has to be equal. Shadow length may be different, we don't know. But this ray we need to look here, this ray. Light ray must be coming in this direction. If this wall is not there, then extra this length will come on the ground. Then this plus this will be total length on the ground. Now it's over. Now once you draw this triangle, then you can apply the concept of similar triangles, because it will be coming at a particular parallel rays it is, right? So as it is coming like this way, you can say that this angle theta will be some constant angle, right? So this by this is equal to, uh, we can solve that. It's not very difficult. We need to solve, find length to solve. Suppose this is x. Yes. Yeah, anywhere you take. This is parallel on. Yeah, you can equate it. 1.8 by, this tan theta you can calculate, and then from there you can also calculate that. Yes. This divided by this and this divided by this. That you can do, correct. So 1.8 minus 0.75 divided by 1.5 is equal to 0.75 by x. Calculate this. X you calculate. X will be 1.5 into 0.75 divided by, this becomes how much? 1.05 it is, right? When you subtract it, 1.05 it becomes, correct? Check that. Calculate this, how much x is coming. This calculation you have to do. Check the calculation. 2.6. Exactly how much it is coming. Exactly. 1.5.75 divided by 1.05. I think it is coming 1.07 approximately. Okay. Check this calculation. Calculation you check. 1.5 multiplied with 0.75 divided by 1.05. Denominator is 0.05. Huh? How much is denominator? 1.05 or 0.05? This. Final answer we have to calculate this because this is the length of shadow if wall is removed. Okay. So 1.5 plus 1.07. So this will come as 2.57. Yes, this is the right answer. This is the answer of this question. Clear? Yes. So question is not difficult, but interpretation is only the problem. How do we take that? Because diagram is not given, right? If diagram is given, then everything is easy. By reading the things, you have to make the diagram. And previously, they used to give this type of question only where the student will think and they will make the diagram and then they will do calculation. Nowadays, if diagram is given, then you will never think. You have to just do calculation. So they are killing the thinking skills. The thinking skill is killed if they give the diagram. If they don't give the diagram, then a student will think, oh, what is right, what is wrong, let me try this way, that way. These things were there previous in the competitive exams. But nowadays, just making things objective now, that we are diluting things. So if you want really to develop your good concept and thinking skill, you take subjective portions. Okay, that will be very good. Nowadays in NEET also they are making big statement based question. They may not give diagram also. So you have to try like that. Okay. So let us move next question. Yes. Ah, this angle theta is same because see this line is there now. This tan theta. This is same triangle because these lines are parallel lines. These are parallel lines, and this is a transversal. This is what is tan theta. This is tan theta only. This tan theta is in big triangle here. This minus this divided by this line and this. Uh, hmm. Yes, you can do this calculation. Okay, fine. That can be done. Done. So let us move then next. Any other doubts if you have, you are asking this. Let's go for next question. Question number 2. A point object O. There is a point object O kept in front of a plane mirror. AB having length. Here diagram is given. This length is like inclined mirror. Line AOM makes angle theta. This angle is theta here. This is theta. 60 degree, theta is given as 60 degree with the mirror, and observer is walking along the line. Observer is walking along that line, perpendicular. Find the length of his path along XM axis in which he can see the image of the object. Given AO is equal to D is equal to 1 meter. Because D is given as 1 meter and that is 2D. Let us try this. So observer is walking along this line and where he will see the image of this object. See, this idea by which we can solve this question is based on field of view. Field of view is an important concept. I will briefly also explain field of view concept because I think field of view I have not covered that. So something we not covered I will cover now also. So let me cover the field of view concept. Okay, field of view. Field of view is important concept. Field of view of an object and image with respect to with respect to mirror. Field of view I will write short as FOV. So field of view of object. Let us discuss field of view of object with respect to mirror. With respect to mirror. Then with respect to this image with respect to mirror we will discuss. So suppose if there is an object, and let us say that there is a plane mirror like this. It can be any type of mirror, but this is plane mirror. So field of view is that space in which you can see this object with respect to mirror. Object you want to see. So first what you do is you try to connect this with the edges of this. Edges. Note that A and B are the edges of this mirror. Mirror is finite length. Okay. If you want to see this object, where you have to be? You have to be present in this space. Okay. This is space. So this space is the region where we can see this object. So what is field of view of object with respect to mirror? It is the space. It is the space in which an object can be seen with respect to mirror. With respect to mirror. Okay. So what we need to do is, if a person wants to see this object, he has to be present in this space. So this entire space, entire space is the field of view. Field of view of object. With respect to this mirror, with respect to the mirror. Okay. This is called field of view. Field of view is nothing but the space in which object can be seen relative to the mirror. Then what is field of view of image? Second thing is that field of view of image with respect to mirror. With respect to mirror. This chapter is very big. Many concepts are there. When initially I used to teach, I never used to cover all these concepts. After when I seen some of the good books and they given lot of theories in that and problems are based on that, then only I started covering these things. Otherwise, we can quickly finish this chapter like in NCRT. They have not covered much content in this. Okay. So field of view of object is over. Now field of view of image. So suppose if this is a object, let us consider, and this is the mirror we take. Mirror you take AB. So now what you need to do is, now you try to first make the image. So you know that for a plane mirror, image will be exactly the same distance. This is the image. So object distance and image distance are equal. That you already know that, right? So what you need to do is now connect this image. Connect this image with the ends of this. Try to connect this image with the end of this mirror, like this. Okay, ends of this. Now, if you want to see this image, you have to be present in this space. You need to be present in this space. If you are present in this space, you will be able to see that. Okay, you will be able to see that image. Definitely, you should not be present here, because if you present in between, you can obstruct the rays of light. Okay, so here also you need to be present. Of course, if you may be present here, so if your eye is like a point, then you can be present anywhere. So you can say that this entire space is representing the field of view of image with respect to mirror. Okay, so this field of view idea is a very big idea by which we can solve problem, and this question we are going to solve using this. Definition of field of view is same. It is the space you want, you write it. It is the space. It is the space in which the image can be seen with respect to mirror. With respect to mirror. Okay, so the concept is the same. Now, you how to use this concept, that we are going to see. So, try to understand how to draw field of view of object. Draw the lines joining the object and the edges of the mirror. Similarly, if you want a field of view of image, draw the line joining the edges and the image. Then you will be able to get it. Let us come to this question and see. So this is what we need to do. The person has to see this image, they are saying. So where the image will form, image will be formed exactly inside somewhere here. Image will be formed here. This is the image. Now we need to connect the edges. Remember, the edges we have to connect. Edges. I'm just trying to draw a rough diagram. Okay, so edges we have to connect with the mirror like this. Similarly, you have to connect this edge also. It may go like that way, far away it may go, but you have to try like this only. Okay, this line will go and it will be cutting somewhere else. Okay, like this. So the length of that line, which that we have to calculate, length of that line. Maybe I can draw a little bit, I can reduce size of this. Might be I can make it little size. I can just try to, you know make it like this. Perpendicular we have to do definitely. Perpendicular, maybe it will come here. This is the image. This distance we need to consider equal. Now let me draw the line. So here I draw this line, it will come, it will hit here this point. Similarly, I need to draw this line here also. Somewhere else it will going to hit it. Somewhere here. I'm taking just a rough diagram, okay? Rough diagram I'm taking. This is a straight line, okay? So I need to find the length of this line. That is what the question is saying. This length of line I need to calculate. How do I calculate the length of line? That we need to think about it. Okay, think about it. How do you calculate the length of line? Okay, so let us try to do some calculations. So this distance is d, this is theta. So definitely, uh, how to do? How to do? Can I make a parallel line like this? If I make a parallel line, then definitely this triangle, this triangle, this triangle, and this triangle will be similar, isn't it? This triangle and this triangle I can definitely make similar, right? Because I can make parallel to this, right? Can we try this? These two are parallel, I can take. So with this horizontal, it will be making angle theta here, like as this line is making theta. So if I can calculate that line, then I need to calculate this one. So I need to think about this angle and we can possibly do it, right? So how do you calculate that? Yes, how do you calculate? Or you can stretch this line also like this way. You can also stretch this like this. Okay. So tell me, how do you calculate this? Apply some geometry concept and do that. Hmm? Then you do it. This distance is given 2d and this is d, so this is also d. This distance is 2d, so this is like midpoint here, right? This is midpoint. So what? Then This is 90 degree. This is also 90 degree. This is theta, and I think here uh, this is 90 minus theta. It will be, this is 90 minus theta, and this is also becoming theta here. Okay, so these two triangles will be congruent anyway. Yes, what can we do? Think about it. Come on. Any idea? You can draw a rough diagram again and try to do this calculation. See, if I take this is d, then this is also this is d cos theta or sin theta. This is d sin theta. This is d sin theta, and this is also going to be d sin theta. So in this triangle, it is the midpoint of this line. Okay, this line midpoint. That means this is also the midpoint of this. How much? That is, we can try to calculate because this is 90 degrees. Okay? This is 90 degrees. When you think about it, ratios of the sides we need to calculate. And also see this sides is also equal because of congruency. So this is d sin theta, d sin theta. This is also d sin theta. Okay, right. This is theta. So tell me, something is coming here. What is that? Can you think about it? Yes. And they have also given this length. This length also they have given. So if I take this triangle and this triangle, then this is the midpoint, right? So this will be half of this. Similarly, if I take this triangle, this, so this is also half of that, right? So if this is half of this and this is half of this, so will this line will be double of that, isn't it? Because this is half of this and this also is half of this, but total length is this plus this, so total, I think this total must be 2L then, isn't it? This length looks like to be now 2L. This length will become 2L. So this is L, this will be 2L. Okay, and if that is 2L, then uh, this angle is theta. Can we now try to calculate these angles? If I calculate this angle, game is over. Definitely we can try. It's not very difficult. Think about it. And note that this length is d cos theta. This length is d cos theta. So this length is going to be double of that. This will be 2d cos theta. Definitely this will be 2d cos theta. D is given, angle is given, so I think we will be able to calculate that. Okay. So this length also we can calculate because this will become L minus d cos theta, right? And this length will be double of that, so this length is going to be 2 times L minus d cos theta. This length. Okay. So now tell me what will be this length in this triangle. Can we calculate? Because this triangle is also going to be similar. So this by this ratio or this by this is equal to this by this. Correct? Can we calculate this? Or can we calculate means here, because this length is in this triangle we can see that, right? So definitely this length, can we calculate somehow this length? Can we calculate that? The possible, and I think here this is 90 degree. So this is 90 minus theta, so this is also theta, right? So this angle is also going to be theta because this is 90 minus theta, this is perpendicular. So because we know this length 2L minus d cos theta, we can take its component because here it is 90 degree. This length we can definitely calculate from here to here. So that will become 2L minus d cos theta multiply with sin theta. So we got this length. Okay, we got that length. What else? What else can we do? Can we calculate this length also? Because this length is d. How much will be this length from this triangle? Figure out that. I think we need to take the ratios, and the ratio of this side by this total will be this ratio by this ratio. So let us say that this length is x. This length is x. Okay. And if we can calculate that x, then possibility is that then we will be able to calculate because up to this much we have calculated. Okay. This length also we have calculated. This length we have to find out. Right? And this is 90 degree by the way. This is 90 degree. Okay. So can you calculate this? How much it will be? Yes. X we can calculate. How? Because d divided by x in this triangle is equal to this divided by total length. So that length is 2L minus d cos theta divided by 2L. So from here we will be able to calculate x. Because 2 will get cancelled. X will come d into L by L minus d cos theta. So x we have got it. Okay. And this length also we have got it. We need to now figure out in this triangle. So see, I think we will be able to calculate this length also. This length we calculate, this length we calculate. Can we calculate this length? That length you can take as y. This length you can take as y. Right? So can we calculate this length from here to here? That length will be how much? Because this ratio will be same way ratios. Okay. So and this length we already know. So we can also take that. Let us consider that as y. Let us consider that length as y. Which length y? From here to here. This length, sorry, this is y na? Already we have taken. Let us consider this as z. Z. So what will be z? Can we calculate now? Calculate z. So this small length by total length, that means 2L minus d cos theta into sin theta divided by z is equal to this length by total, that ratio is same, L minus d cos theta divided by 2L. So we will be able to calculate z from here. Z also we got it. What is z? Z how much it is? Figure out z. Z will be 2L minus d cos theta into sin theta divided by L minus, multiply L also, L is multiplier, L minus d cos theta. So this is what is z. We got length z. What will be y? How to calculate y? Yes, any idea how to calculate y? How do we calculate y? What is this angle? These angles I think are parallel lines. This, if we can calculate this angle, let us call this as beta. Beta. Can we calculate beta? Yes, I think we can calculate beta because d sine theta by d cos theta, that is tan. Correct, right? This is tan only, no? Isn't it? So this and I think this angle is also going to be theta only, because this by this ratio is giving us tan. So I think this beta is theta only. So no need to worry now. We have got this angle as theta only. Okay, then beta is theta only. So calculation becomes very easy. So y we can calculate now. Y is equal to x tan theta, because this by this is tan theta, right? So x by y is tan theta. Okay, x by y is tan theta. So y will become x by tan theta. Okay, so y we got. Now we calculate the answer finally. So the answer is z plus x. That is the answer. Let us do z plus x. So the answer will be z plus x. Sorry, z plus y. Sorry, z plus y. The answer will be z plus y. So z already we have calculated, L minus d cos theta into L sin theta divided by L minus d cos theta plus y. Y is what? X by tan theta. And x already we have calculated. What is x? X is this. So we can substitute x and try to simplify this. So 2L minus d cos theta into L sin theta by L minus d cos theta plus x. X is dl or LD by L minus d cos theta into tan theta. Now we can substitute the values and get the answer. L is given, D is given, theta is given, length is given, everything is given. We will be able to calculate it. Clear? Are you clear about this? So this type of questions which involve lot of geometry is involved. That is why it is called geometrical optics. This chapter is called geometrical optics. Why? Because lot of geometry is involved. You have never, you have studied, right, that this chapter is ray optics and also it is called geometric optics, because lot of geometries are involved. Okay. What to do? Geometry calculations are long only. You need to see some triangles. Somehow, if you can do it, then it is better. If you may think of something else of doing that, similar triangle property is there. But we need to try to break it into similar triangles. Here, when you draw this line, image, first of all, you have to form the image. Without this image, you cannot do. First, you need to form this image. And then you need to connect with this edge like this. Okay, and once you connect with this edge like this, then only you can think of doing calculation. This is definitely a lengthy calculation. Okay, fine. So some questions like, then you can substitute the values. No? What are the values? L is 2 meter and angle is 60 degree and D is 1 meter. So let us substitute. L is 2, D is 1, angle is 60. Let us substitute. L is 2, D is 1, cos 60 root 3 by 2. I think calculation also may go very big calculation, isn't it? Sin 60. So this angle is 60 means cos will become half. Cos will become half. L is 2, sin will become root 3 by 2. L is 2, this will become half plus L is 2, D is 1. This will become 2 minus half. Tan 60 degree will become root 3. So this calculation we have to do, which will give the answer. Okay, so check out this. I think this term is coming exactly same now. Anyway, these terms are getting cancelled. Okay, this term let us cancel out. Hmm? This term got cancelled. This got cancelled. This come 2 root 3. This came as 2 root 3 plus here it becomes 2 and it becomes how much? 2 into 2, 4 minus 1. 3 by 2. 3 by 2 root 3. So this is 2 root 3 plus 4 by 3 root 3. Take calcium. So 3 root 3 and multiply 3 into 2, 6, 6 into 3, 18, 18 plus 4. So final the answer will become 22 by 3 root 3 meters. That's the answer. Of course, this question was little complex questions. Okay, but the approach is the same. Approach, even if question may be simple, the approach will be the same. Done. Let us move next. This concept is over. Next question. Next question. Try this. Next question. All of you try. Two large plane mirrors OM and ON are arranged at 150, 75, 75. Okay, let us try to do now fast. Okay, you also try to do. I will also try to do fast. SS dash. SS dash is a long line perpendicular to the line OP. Okay, find the length of the part of the line SS dash. Part of the line SS dash on which two images of the point object can be seen. Again, this concept is based on the field of view of image. Field of view of image. Let us try. First of all, make image with respect to first and then with respect to second. But symmetricity is there here. Because of symmetricity, the calculation will reduce definitely. So first of all, where the image will form here, you can say that image, this image is first image will form. Similarly here on this perpendicular line, second image will be formed, and these two images will be equally separated. These distances and these distances will be equal, but let us forget about those things. Concept is that we need to join with the edge. Remember the concept. Try to join with the edge. This image, try to join with the edge, these two edge. So make here and make here, somewhere here also like that only it is going. Okay, somewhere it is like going like this. Again you try that for that one. Here with this image we can try to do like this. So that's all. Now they are asking that two images the point can be seen, where we can see both the images. So if you want to see this image, you have to be present within this space. I think you are able to visualize the lines which I am drawing, right? Okay, so this space you have to be within this space. Within this space means within this line. Within this line means I will show dot dot. Okay, dot 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 means on this much length it has to be this much length. Within this length you will be able to see I2. Similarly I1, where you can see I1. I1 will be seen within this space. Within which space? Within this space. Within this space I1 can be seen. So I1 can be seen within this space and I2 can be. Now we take a common overlapping region. You take overlapping region means what? Overlapping region where red and this dot is overlapping. So this is the region where they are overlapping. This length we have to calculate by geometry. Once you do that, game is over. That is what you need to calculate. Okay. So how to calculate this is now our geometry. Geometry it is okay. How to calculate that length is geometry. So use geometry. What are the things given? Large plane mirrors arranged by 150 degree. TJ point asserted long perpendicular to the length they have not given. Asserted on these two images. How to calculate length? Nothing is given. Na? Only angle. Oh, D is given. D is only given. You have to get the answer in terms of D. Okay. We need to get the answer in terms of D. So think about it. How to get? Hmm? How do we get? Think about it. It is a similar type of model of question. It is, isn't it? You have to think in this some approach. Mirror length they have not mentioned, but they have mentioned 75, 75. Large mirror they have told. That length we need to calculate. How do you calculate geometry? Can you use some geometry? Only distance D they have given. And from that D only we have to try to calculate, because this distance will be D. And is the P midpoint? Is the P midpoint? P is a point object and perpendicular. Find the length of part of. They have not mentioned where it is. Looking like it is like the midpoint. It's looking like that P is like the midpoint. Okay. It looks like P is like the midpoint. So if it is looking like that P is the midpoint, assuming that P is midpoint, I think some symmetricity is looking. So this distance will become d by 2 from here to here, right? And if this distance becomes d2, and note that this length is perpendicular here, this line is perpendicular we have taken. This angle is 75 here, right? So again I will try to take cos and sine. Let us take this as theta, 75. So this is perpendicular. So this will become d sine theta and this will become d cos theta. I think similar approach we have to apply. Okay, similar approach we have to apply, and we need to find out, basically we want to find this length. So somehow or the other we need to find, if I extend this line like this way, so this is theta, this is 90 minus theta, so this is 90, so this is also going to be same angle theta. And by symmetricity, because this is like these lengths are equal, I think exactly coming same approach, d sine theta, this is also d sine theta. By congruency, this will also be d sine theta. This length is going to be d sine theta anyway, because this is d, because this is the midpoint. So this is, I think, d by 2, not d, because half of that d by 2 sine theta it is. This is d by 2 cos theta. So this is d by 2 sine theta. This is anyway d by 2. We know that. Okay, right. So we will be able to calculate the d by 2 sine theta. In same manner, we need to find out this length, right, and this length. These two lengths we need to calculate. And by symmetricity, I think these two lengths should be equal. Let us consider them as y. If you can calculate that length, then we can able to find out that. Correct? So I'm leaving this calculation to you. Definitely it can be done just like the previous approach we have done. Same way you try to do that. Okay, it is possible to do that. Like for example, here this is d by 2 cos theta. Again we can draw a line from here like this, and we will be able to find this length. Definitely you can find out this length, how much it will be, because this is d by 2 and this is d by 2 sine theta. Check, let me check this whether I have done correct calculation correct or not, because this is hypotenuse, right? This is hypotenuse here. So d by 2, this angle and this angle are equal, this are equal. This angle is 90, this angle is 90. This is d by 2 sine theta. Is there any mistake I have made? This length and this length will be equal, no? Because this length is d by 2, this length is also d by 2. How can this length hypotenuse become smaller than this? I think there is some glitch happening here, isn't it? Because this angle is theta, this is d by 2, this is hypotenuse. So this length is d by 2 cos theta, this is d by 2 sine theta. That is right. And we can see by geometry that this angle theta should be same by, because it's a vertically opposite angle. 90 minus theta, that means 15 degree. This must be 75 degree, and this is d by 2 d by 2. This is d by 2 sine theta. Oops. Is this length exactly same as this? Just check about this. Opposite of this is d by 2 cos theta. Opposite of 90 it should be d by 2. I have made mistake, I think. They are similar, but this is opposite of this. This is d by 2. This length is d by 2 here. Okay. And then this length will become d by 2 sine theta. Okay. This is opposite. Yes. So this point, but initially we assume this is the midpoint now. Yes. Correct. This we assume initially as the midpoint now. Correct. So d by 2 it should be now. Where is the mistake has happened? because this length is d by 2, this length also should be d by 2. And when we are taking perpendicular like this from here, this is d by 2 cos theta, this is d by 2 sin theta. And this triangle, this is vertically opposite angles, right? This is vertically opposite angle. This is perpendicular here. Here also this is perpendicular. This is 90 minus theta. This is theta. Some dates is coming, I think, in this. Huh? Check that. Previous was correct. Here also, anyway, they have not mentioned that what length it is, the point P. But we are taking it symmetric, right? They have not mentioned two large plane mirrors, one face of 150 degrees, so on. P is a point object in SS test is long perpendicular to line OP. Find the length of part of the line. They did not mention, I think. They must mention it. If it is midpoint, then this length and this length should be equal. Somewhere some glitch is looking like that in this diagram. Okay. So I'm leaving this because it is looking like some issue is happening with this diagram. Okay. Are you getting this? Are you understanding what I'm trying to do? Yes. But this question is very nice questions. You may say that this type of question doesn't come. Yes, this type of question doesn't come. But the concept application you will learn by solving this type of questions only. If you really want to learn the concept, then you need to solve this type of problems. Okay. So the idea will be that when you take a perpendicular here like this will be first image. Similarly, when you take perpendicular here, this will be your second image I2. Right? These two images are there. Now you need to connect with this mirror, this end of the mirror and this end of the mirror. Okay, this end of the mirror and this end of the mirror with this line. You need to construct like this. Okay, right? Similarly, you need to construct this end of the mirror and this end of the mirror with this line. Okay, so wherever overlapping happens, that common region we need to see. And I think the common overlapping that is happening is the smaller side this side and smaller side this. So this is smaller length. That length only we need to calculate. Okay. Some geometrical calculations are there, but now you think of what is the geometrical concept we can use. Okay, so I am leaving it. We'll think about it afterwards. Okay, it will take more time also. Okay, so let's move to the next question. But definitely they have not given the distance of p. So if I take half, with that I can proceed. That is one way of doing that. But if I proceed with that, note that this I have to take 90 degrees. So this angle 75 is theta. And if I take d by 2, this I have to take as d by 2 cos and this I have to take d by 2 sine. Right? That's how I can do, isn't it? And then we need to extend it this side. And if I assume that, and just let me try once more. And if I assume that this is a straight line, this line is a straight line like this. So if I take this as 90, this I have taken as d by 2. This I have taken as d by 2. This length I have taken as d by 2. This length also I have taken as d by 2. Because this is vertically opposite angle, so this angle is theta. This is 90, so this is 90 minus theta. And this will be 90 minus theta, and this is 90, so this must be theta. Right. So isn't these two triangles looks congruent? They must be congruent, isn't it? They must be congruent. So this is d by 2, this is d by 2. These angles as they have so many properties we can apply. So we can definitely figure out that this length, what is there? What is that length? D by 2 cos theta. This length is d by 2 cos theta. So this length also must be d by 2 cos theta, right? This length should also be d by 2 cos theta. Glitch is there. There is a glitch looking. Why? Because see, this is d by 2, that is d by 2. These triangles have become congruent. So this is d cos theta, that should be d cos theta. This is the sine theta, that is the sine theta. Glitch is there. Looks like there is a glitch. Okay, in the problem setup. Anyway, but if you can calculate this d by 2, and then what will be this length? This length you can calculate. Okay, can we calculate this length? Yes. Can we calculate this length? And if by symmetry we are taking that these distances are like a equal distance, then can I calculate? I can draw a parallel line and calculate. Is this line parallel to this line? Might not be that. Okay, might not be parallel. I think glitch looks like there only where, because this line is not parallel. We need to consider a parallel line. A parallel line we need to might be there similar. Okay, but we need to draw a parallel line like this. Parallel to this, if we draw, then maybe we can do something like parallel like this. Then we can take perpendicular on this, and then we can do some calculations. Okay, so I'm leaving it. Some glitch looks like that. Let us move to the next question. I is a ray incident on a plane mirror. Keeping the incident ray fixed, the mirror is rotated by an angle of theta about an axis passing through a perpendicular plane of the figure so that the refracted ray rotates through an angle 2 theta. Does your answer differ? The mirror is rotated about an axis passing through B. See, the question is, I think this result you know. If you rotate the mirror by angle theta, the reflected ray rotates by 2 theta. This all of you know, right? That result. Yes? Sam, Chatresh, Monish, Lalit. Suppose if I draw normal like this. Suppose if I rotate this mirror, then this mirror, let us say anti-clockwise rotate. This mirror will come like this. Now the normal to the mirror will be like this way. Normal to the mirror will be like this way, because normal also will rotate by same angle. So if you rotate this by angle theta, normal will also rotate by same angle theta. This is the normal. Okay, n is the normal. Incident ray we are not rotating. So can we find out what is the angle by reflected ray? So suppose this is incident here, this ray is incident. So this ray will be coming like this. This is reflected ray. First case reflected ray. So how much angle it is making? They have given how much angle it is theta about an axis. No, they have not given angle of incidence. Let us take that initially this is the angle of incidence. So this is the angle of incidence here also. Okay. So now if you rotate the mirror, this is the mirror. Okay. Mirror we have rotated. So the new normal has rotated. Now with this new normal, how much this incident angle it is making? This is I, this is theta. So this angle is I minus theta. Right. So with the new normal, this new reflected ray will make same angle like this. So this angle is also going to be same as I minus theta. I minus theta. So what we want to find out that previous reflected ray and now reflected ray, what is that angle? How much will be this angle? Can you calculate how much is this angle? Yes. Can you calculate what is the angle between the reflected ray previous and now? Yes. See, if this is I minus theta, this angle is how much? This angle is 2 times I minus theta. This angle is 2 times I minus theta, right? 2 times I minus theta. How much will be this angle? Suppose this angle is alpha. Let us say this angle is alpha. So sum of alpha plus 2 times I minus theta must be equal to this I plus I 2I. This way we can try that. So sum of 2I minus theta plus alpha must be equal to I plus I. So try this. So this becomes 2I minus 2 theta plus alpha is equal to 2I. 2I get cancelled, alpha is equal to 2 theta. We know this result. Okay, we have proved it. But the question is that now the question is little bit different. We are rotating the mirror about this axis. Never anybody would have thought it. So this question is quite interesting question. If you rotate about point B, then what happens? Then what happens? Huh? Yes, you have not thought about this. Nobody has thought about this. About which axis are we rotating? Because rotation always happen about an axis. Now axis itself I am changing. I am rotating about this axis. Then what happens? Let us think about it. I will try to do that. Okay, so suppose this is a mirror and this is the point about which we are rotating. Now I will rotate this and I will make another. So I have rotated and this is the new mirror. This is the new mirror. Okay, and which was this old mirror? This was old. See, these are important, very important. Nobody pays attention to formulas. Formulas are derived for a particular case. Suppose previously this ray was coming and it was making an angle of I. Suppose I draw this normal, okay? This is the previous normal. It was making angle I with the normal and the reflected ray was going like this way. Reflected ray was going and this was also making angle I. Okay, now let me rotate this mirror. I have rotated this mirror about this point and this rotation angle is theta I have done. Now what happens? See, the incident ray is still the same, not that incident ray is still like this. This is the same incident ray, but now let us draw normal. Let us draw normal here now. What do you think that this normal will make? This is the new normal. Previously, this was the normal. What will be this normal make angle with this incident ray? Tell me. What do you think? Will this type of question comes in need? Of course, it looks like a theoretical question, but we need to verify whether this result is still the same alpha will be 2 theta or not. Yes, what do you think? Tell me. If the result remains same or result different, because rotation happens about different axes. How do we know? We need to know it like that. If the angle between normals remain the same, that means is the normal also rotating by same angle? That how do you know? That we know by simple property of two lines. Angle between two lines is angle between their normal. So on this line this is normal, on this line this is normal. So still the angle between this normal is same. If you want you can extend them and so that. Or if you want you can draw like slide this vector here. You can slide like a vector. So this line I am sliding it now here. I am now sliding it here. Note that this is parallel. Okay. So still you need to note that this angle is going to be theta. It is going to be theta. But now what about this angle? Angle between this. Uh, Previously it was I, but now how much it will be? So previously this angle was I. Which angle was I? This angle was I. And this is theta. So this angle becomes I minus theta now. So now the reflected ray will be going like the same manner it will go, right? Now the reflected ray will go in the same way. So this is normal, so it will be going like this way, right? So this angle which is now I minus theta, so this is also I minus theta only. I minus theta, right? So how much is the angle made by this reflected ray and this reflected ray? Both are reflected rays. So how much it has rotated? Yes. So I can also slide this and make parallel here like this. How we have done it like this also we can slide it and bring it parallel here. Parallel line we can bring. So this was making the same angle I also here. Correct. This was making same angle I. Okay. Now this is the new reflected ray. How much it is making with this new ray? What will be this angle? We are taking as alpha. Okay. Now tell me how much it will be. So see, this is I minus theta and theta. Right? That is total angle I plus I. Here also we can take like this. So see that this angle I, this angle is also I, and this is I minus theta alpha. Let us add them. So I plus I is equal to I minus theta plus I minus theta plus alpha. Are we getting the same result? Yes, we are getting the same result. Now we are very sure that whether you rotate the mirror about any axis, it doesn't matter. The reflected ray rotates by the same angle to theta. There can be no confusion. Are you understanding this? Yes. You may say that it is very tough. Who will do that analysis? Because NCRT have not done it. NCRT have not done it because it has left it to the student to do it. Are you understanding that? You may think who will do so, then you don't think of achieving good results. Then if you want average or below average, then you don't have to do this. Okay, so if you want that I want to get a good result, I have a passion to get a good result in exam, then you need to really work hard and do analysis. For somebody you can give him the answer that if you rotate about any axis mirror, doesn't matter, the results remain same. But why the results remain same? This is the proof of that. You take about any suppose in your board exam, if they give the proof that rotate the mirror about this axis and prove that this angle alpha is 2 theta, then this is the only approach which you have to do it, right? Yes, Sam, Monish, Chris. Okay, let us move next. Next, this question, let us try question number 5. The inner surface of the wall. Try this question. The inner surface of the wall of a sphere is perfectly reflecting. Radius of the sphere is r. A point source S is placed at a distance r by 2 from the center of the sphere. Consider the reflection of light from the farthest wall followed by reflection from nearest wall. Where is the image of the source? Consider axial rays only. They have clearly given that. So this is the sphere. Maybe I should draw a bigger sphere. This is a sphere. Okay, and let us consider that this is like the diameter passing through the center. Okay, and they are saying that radius is r and all those things are there. Point source is placed at a distance r by 2 from center. So suppose I keep an object here. This is the object. This is at a distance of r by 2 from this side. So this side is also r by 2. Okay, this side is also half half. Okay, and here they are considering that inner surface is reflecting, means outer surface is painted. Outer surface is painted completely. Okay. Okay, that means it's a concave mirror. It's going to be a concave mirror. Now do the calculation. They are saying that first rays will go and hit that surface, farther surface. That is farther surface. So this distance is r, right? So this distance of object from here will become r plus r by 2, 3r by 2. So now consider this as the pole P, and first let us take this is pole 1. So first you consider reflection from that surface and tell me where the image will be formed. Radius of curvature is r, so focal length of this will be r by 2. Do the calculation quick and let us find out where the image will be formed due to that reflection. Let us try that. So 1 by V plus 1 by U is 1 by F. So for that surface I am taking, so object distance is minus 3r by 2. We will calculate. Object distance is minus 3r by 2. So V is going to be minus 3r by 2 U. Focal length also negative, so focal length is minus r by 2. Okay, calculate this. So 1 by V will become, that side it will go. So 2 by 3r minus 2 by r. Calculate it. Take LCM 3r. Take 3r. So 2 minus 3 into 2, 6. So minus 4 by 3r. So V is coming as minus 3r by 4. Minus 3r by 4 means what? Minus 3r by 4 means this is r now. So minus means somewhere here. 75% of r means here it will be. The image will be formed here. This is, let us say, first image. Negative means it is showing this side. So this image is forming at a distance of 3r by 4. 3r by 4. Clear? Are you clear about this? Yes. This image I1 has formed. Next, this image is getting reflected with this surface, and then final image. Where is the image of this final image formed? So now what happens? Note that rays will be going like this way. The direction of rays are important. So rays, how will you take the rays? Rays you have to take it like this way. Okay. So first rays gone like this way, reflected. Now rays are coming like this way. So this direction you have to take as positive, and this direction you have to take negative for this second. This is the pole, second pole. Now do this calculation for second pole. Quick calculation you can do. Let us do this quick calculation. For this, object distance is going to be negative. So tell me how much this distance will be, because this is 3r by 4 and total is diameter, which is 2r. So tell me how much this distance will be. That distance will be 2r minus 3r by 4. How much that will be? 8 minus 3, 5r by 4. So 5r by 4 in the negative direction. So now you substitute 1 by v minus plus 1 by u, but object distance is going to be negative 5r by 4. 5r by 4 is equal to 1 by focal length for this side. Focal length is still negative for this side. So focal length is going to be negative. So minus r by 2. Now you calculate, this will be the answer to this calculation. So 4 by 5r minus 2 by r, take LCM, 5r, 4 minus 5 into 2, 10. So it is coming minus 6 by 5r. So finally we are calculating this v is equal to 5r by 6. But minus means the same side. So finally the image is coming as 5r by 6 distance from this side. 5r by 6 means how much? 5r by 6 is how much? 5 by 6 is how much? 0.4, nearly 0.48. Correct, na? Because 6, sorry, 68 is a 48. 0.8 something it is. 0.8 something it is, and r by 2 is like 0.5. So somewhere very, very close this side. This is the final image I2 we are getting. So finally, we have got the image. They are asking image. Where is the image? So if I consider this as a sphere, then this is the center. Let us say O, and this is the final image I2. This final image is 5r by 6 distance. 5r by 6 from the surface, and total from center, if I have to calculate this distance, so how much will be this distance? Because total is r, so r minus 5r by 6, so this is going to be r by 6. So the image is finally formed at r by 6 distance from the center towards the side of the object. Are you clear? Yes. Are you getting this? Yes or no? This is what is called geometric optics. When you work problem and see the geometry, it is not the 10th grade type of questions will come. Geometric optics means you need to visualize reflections and which direction rays are going, which direction it is reflecting. All those things, calculations you have to do. Unless you think yourself, it will. That's why you take time. It is not that you have to rush in. That's why we will go slow. Question solve and try understanding. Take time. It takes time to grasp. These days, teaching is not proper everywhere. They are just bombarding students with formulas and these things. They never get any time to think anything. Self-study is also reduced because all the time school hours are so much. It will never get. In our time, we did not have that many school hours. In our time, we had only from 8:30 to 2 o'clock maximum we had school hours. After that, we have full time free. So when we came to home, we take rest, and after that, full no 8, 9, 10 hours also we could study. It was like that. That's why we used to study 10 hours. So we used to study so many books by ourselves. We used to take big books and we used to study this that. No, chemistry I never means used to score good marks. But I liked chemistry theory. I used to read these books of chemistry. Different books I used to read. Chemical kinetics I used to like. One book I remember I studied Peter Atkins. Peter Atkins book is a very good book that gave me so much knowledge and analysis of this chemical kinetics reactions like that. And some foreign author book also was there. One Chinese author book I don't remember. It was also a very good book. There were so many books were there, but few books I like. I just used to read it just for knowledge. I used to read it. But I could not score more in chemistry. Okay, because chemistry is so much to remember and so many reactions are there to remember this. It's okay. We have to balance things, right? If some subject we are not able to score good, other subject we have to score good. You have to balance it. Okay. Then what? Shall we take one or two more questions? Okay, let us try this question. Last question we will take question 6. A concave mirror forms a real image on a screen of thrice the linear dimension of a real object placed on its principal axis. The mirror is moved by 10 centimeters along its principal axis, and once again a sharp image of object is obtained on the screen. This time the image is twice as large as the object. Find the focal length of the mirror. So they are talking of a concave mirror. Okay, there is a concave mirror, and this concave mirror is forming what an image? Real image it is forming. Real image on the screen of thrice the linear dimension. So magnification is going to be -3 first time. It is given -3. Okay, right. The mirror is moved by 10 centimeter along its principal axis. So we are increasing the distance along this and once again a sharp image of the object is obtained. This time the image is twice as find the focal length. So what do you think distance what is moved? Which direction it is moved? Suppose this object, definitely the object is beyond the focus, right? This is focus. This may be center. What about where can be the object? What do you think? Where can be object? Where we are getting magnified images? Yes. Where can be the object? Yes. If you want, you can calculate magnification formula is f by f minus u, right? F by f minus u. Focal length is negative, so let us put f as magnitude, so minus f minus u, right? So that becomes f by f plus u and solve it. So f plus u will become minus f by 3. So u becomes minus f by 3. So how much it becomes? Minus 4f by 3. We can calculate. So right now object is how much distance, that also we can figure out. So 4f by 3 is 1.33. That means somewhere here object will be there. This distance of the object from here is 4f by 3. Right now this is the distance of the object. Okay. So now if you have moved separated, so image will be real inverted this side beyond center it will form and it's magnified. Now we are increasing the distance by 10 centimeters. Now question is that are we moving this side or are we moving closer to the object? Mirror we are moving, but are we moving the mirror away or are we moving closer? That is what is the question. We have to think about it. Yes, what do you think? Should we move the mirror closer? If you move the closer, then if you keep at focus, the image will be formatting it infinitely. So might be it goes this way, and then virtual image will be formed. Possibility that virtual image can be double. That is one possibility. I'm not saying that that cannot happen. That can happen. Another way is that if I push it this side if I push. So let us try to think both cases. If I keep magnification as -2 and +2, what can happen? Let us calculate for -2. That means in this formula, put magnification -2 and do the calculation. So I am just going to reduce calculation here. So I'll put -2. This will remain same. So this will become -2 is equal to f by f plus q. So u will become equal to how much? Minus f by 2, and this plus f will become minus f. So u will become as minus 3 3f by 2. That means now we have to keep object at a distance of minus 3f by 2. Minus 3f by 2 is 1.5, right? This is 1.33. So 1.5 means still it is this side only. Means it is still it between center and focus it is. Because 2f when it becomes, then it is at the center. So might be the object has shifted. Let us say this is the object position 1. Okay, and now object has become here. Object has come here now. Let us see. So I am taking still the real image only. So possibility is that now real image. So how much shifted happen object? How much this mirror we have? That means we have moved the mirror away, right? So if you move the, so we are considering that we have moved the mirror away. So how much distance we have moved? This difference we can calculate. So this is how much? This is 3f by 2. So what is the separation? This distance separation now we can calculate. So 3f by 2 minus 4f by 2, that separation is 10 centimeter. We got the answer. So 3f by 2 minus 4f by 3 is equal to 10 centimeter. So calculate now. So from here it becomes 6. 3 into 3 9, 4 into 2 8, right? That becomes 10. So from here f is of course magnitude here. So f will become here. This is 1 by 6. So 60 centimeter. This is one possible answer. I'm not saying that this is the only answer. But suppose if I move this mirror closer, if I move closer, so this was the initial position of the object. This is final position of object when you move separate. But suppose if you move closer, so take the magnification as +2 and check what happens now. So suppose if I take magnification as +2 now, +2 is f by f plus u. Then from here, f plus u is equal to f by 2. So u becomes equal to minus f by 2. That is also a possibility. So now where the object we have to keep? We have to keep object at a distance of minus f by 2. So half of focus. It is possible that we can keep object here also, right? That means now you have moved closer. So this distance has become f by 2. Right, that has become f by 2. So now tell me what will be this separation. This separation will be how much? This we calculate. Previously this is 4f by 3. Now it is f by 2. So subtract that. So now that separation which is going to be 4f by 3, that which is going as 4f by 3 minus f by 2. This separation will be 10 centimeter. Calculate another possible answer from here. So 6, 4 into 2, 8f minus 3f, right, is equal to 10. So from here, what will be f? So 5f will come, correct? 5 into 2, 2 will come, 12 will come. So f can be 12 centimeter also. So there are two possible answers for this question. Are you getting this? Yes? Are you understanding this question? Okay, so this is a question. It's a good question. So they are saying that there is an object here And if we are moving, and it is right now making a magnification of -3, they have given it's a real. So -3, based on that you have calculated object distance. So object distance comes as 4f by 3. Okay, so that's the actual object distance right now. Now they are saying that we have moved the mirror and there is a magnification of 2, but they have not mentioned whether it is +2 or -2. That means they did not say whether now the magnification is happening real image or virtual image. So we have taken both the cases. Take -2, take -2 for real image, and you got object distance is -3f by 2. So that means this is object has come this side. That means we have moved it away. So now the object come here. So this distance based on that magnification, this we calculated. So separation between these two objects, that is what the distance moved. From there you got focal length 60 centimeters. Now if I consider as +2, if I consider as +2, then I get object as this. It will go within that focal length, right? Because it will form a virtual image. Then it is f by 2. So in this case, we have moved closer. So how much closer we have moved? Same way we calculate this. So you need to really solve questions of good level. There are questions of very good level in NCRT also, but that also in old NCRT book. That also we will see that. But today we have worked out questions and it gave some ideas. So definitely you think about it, ponder about it. You don't have to rush it, but take time, because this ray optics is a high weightage chapter. High weightage means really good questions are coming on this. Fine. Yes, Sam, Lalit, Monish. Okay. So then we will see in the next class, right? If possible, I will try to take more classes this week, because other topics also we will be covering. Fine. So let's meet in the next class around